Good. Why do I say good morning every time? You know why? Because it always is morning, which is why I got my Dunkin' Donuts coffee. I'm ready to rock and roll. I just want to get started. I just want to get going. We're like halfway through this unit. I think we're a little bit past halfway. We are at now 5.5. By the way, all these videos nice and neatly can be found at www.nkinfinity.com. My partner in crime, Miss Vicky Newman, and myself, Mr. Krause. We will make up Mr. Key for today. We've spent a lot of time getting this stuff ready for you to help you out. So hit that subscribe button, hit that like button. Let us know what you like, what you don't like. Don't hit the do not like button. That just makes me mad. Don't want to make the bald math teacher mad. Don't call me bald. It upsets me. All right, let's take a little trip back to 4th or 5th or 6th grade or whatever grade you learn this stuff in. When we add fractions, yay! Everybody likes fractions because it's the F word you're allowed to say in class. You say fractions. I love fractions. See, that makes math fun. Don't curse in math class. Even if you get mad, don't curse. In order to add fractions, you remember, you need a common denominator. So as long as you have a common denominator, you can add fractions. If you don't have a common denominator, you can't add fractions, right? See what I'm saying? So let's check this thing out. Look, we have a common denominator. It makes things so much easier. So if I have a common denominator, I'm allowed to just add or subtract the numerators. In this case, we're going to subtract. So I'm going to keep the denominator, and I'm just going to, in this case, subtract up the numerators. Oh my goodness, I want you to remember this one thing. Please remember this thing. See this thing right here? That's going to be the most troublesome minus sign in your entire life, because this is what you're going to do. You're going to do this. You're going to go 2 plus x minus 2. And that, my friends, would give you the wrong answer. See, if you had a little Dunkin' Donuts, you don't make mistakes. God, nailed it. All right, you have to remember that these are like married couples. Keep them in parentheses until you decide what to do with them. It's like, read. That's what you have. You have 2 plus x minus 2. Now I hope you see, oh, wait a second. You mean I got to distribute that negative to both of those? Yes. And I'm going to talk about what you're going to do later when you get to a problem like that, because man, those negatives are nasty. They will give you all kinds of problems. So this is really 2 plus x minus x plus 2. And the x's cancel, so I really just end up with 2 over 5 plus x. Now, I don't think I have my calculator up, so I'll get that up in a second. Ding, ding. Where am I going? Bing. Okay. We're going to talk about, never mind. No, we're going to do it right now. We're going to verify that we have the right answer. By the way, which we do not. I hope you all noticed that I made a mistake, but I did it on purpose, kids. I did. I really did do it on purpose. No, I made a dumb mistake, but I want to show you why you should never get one of these wrong, or at least you should know you have it wrong. Hopefully you can find your answer. You know, this is just, again, one of those problems where you just say, all right, I can stow any value. Don't pick 1, 2. Pick something stupid like 2.14. Store it into x. And then type in the original problem. Control division. 2 plus x over 5x. The over apparently didn't work. In the denominator, put 5x. You're just going to type this in exactly as it appears. And then we got x minus 2 over 5x. And hit enter. And I get that. And then I say, okay, control division 2 over 5x. And I get, what? I didn't get the right answer. What did I do? Let me go over here and see if I can find my mistake. I did these two. Those cancel. And then I said, oh, okay. 2 plus 2 is, that should be a 4 over 5x. So I come back over here and I say, okay, is that right? So I'm just going to hit the up arrow. It's like my copy and paste here. Change this to a 4. Change this to a 4. Delete 4. Enter. Oh, yes, those match. See, those match. 0.37, 0.37, 38, 31, 77, 5701. They match, yay. So you should really never get it wrong because you should have the at least maturity to go check your answer. Don't know why I pressed that. When I take a break from those complex fractions that I have my kids do, I drink Dunkin' Donuts. It gives me the energy to come back and do better problems. Oh, God. Nailed it again. Oh, Dunkin' Donuts. I don't know how you don't have me as a sponsor. All right, so here we have the very complicated don't have a common denominator issue. We got a 3 and a 2. So this is where I go back to 5th grade and say, okay, you got to make a common denominator. How can I make these into a common denominator? First of all, what is the lowest common denominator? Now, if you don't know what the lowest common denominator between 2 and 3 is, we got some serious issues, kids. Serious. Clearly, it's 6, right? Because 2 divides evenly into 6. 3 divides evenly into 6. So we're going to make them both 6. Well, to make this a 6, I got to multiply by 3. So I got to multiply the numerator by 3. Hence, multiplying by 1. 3D. This one I got to multiply by 2. This one I got to multiply by 2. Hence, multiplying by 1. Really, we're just multiplying each fraction by 1, changing only the look of it, but still creating a fraction that is equivalent. Oh, Mr. Krause, I love when you talk math. It's amazing. So 4D. That makes 4D. That makes 3D. Now that they have a common denominator, I can add them up. 3D plus 4D is a really cool movie. But in this case, it's 7D. Could you imagine a movie in 7D? I don't even know what that would be. That'd be like way cool. All right. So the common denominator here. Let's just take a look. We got 3A and 4A. So what we want to make sure that we do is say, okay, I know that A has to be a part of the common denominator. So I'm just going to take care of that right now. Since they both have an A has to be part of the common denominator. Then I'm going to look at the 4 and the 3 and I'll say, okay, the smallest number that they both divide evenly into is 12. So I multiplied this one by 3. I got to multiply this one by 3, 18. I multiplied this one by 4. I got to multiply this one by, that is a 4. That's not 4 ninths, it's 4 over 4. And that is 8. So what is 18 minus 8? That would be 10 over 12A. Don't think I should leave it like that because it can be simplified. 2 goes in here 5 times. 2 goes in here 6 times. So that's 5 over 6A. It's just beautiful. It's just beautiful. Love math. All right, now we're going to talk about some rational ones, some crazy ones. We got to factor the denominators. Factoring and fractions fun. The triple F. Find the least common denominator. Here's a big important piece. You need each factor of the denominator represented once. As long as it's represented once, it's part of the common denominator. Multiply the top and bottom. Multiply top and bottom for what is missing in the denominator. Rewrite as one fraction and simplify. So we're going to walk through those steps in a concrete example right here. First thing I like to do, and the first thing I demand that my kids do, is anytime you see something that's adding and subtracting, I want you to put it in parentheses. Because what you'll think about then is that as a separate entity. Right? It's not x minus 6. It's x minus 6. It's a thing. It's a binomial. It's a factor. So each factor needs to be represented in the common denominator. So each factor needs to be represented. So I'm taking a look at this one. I say, oh, you have an x. An x needs to be represented in the common denominator. Oh, you have an x minus 6. It's not x minus 6. It's x minus 6. They're married. They're together. Put some rings around them. No divorce here. So that x minus 6 needs to be also a part of the common denominator. All right? So in order to transform and to rewrite this this fraction into this statement, I needed to multiply the denominator times x plus 6. But if I don't want to change it and I have to write it in an equivalent form, I also need to multiply the numerator by x plus 6. Therefore, this is just multiplying by 1 big fancy 1. So if I multiply the denominator by x plus 6, I got to multiply the numerator times x plus 6. To change this one's equivalent form to this, I needed to multiply the denominator by x. So I got to multiply the numerator by x. And I get 3x. All right, let's do some distributing. That's 5x plus 30 plus 3x all over, because now I have a common denominator. I can write it all over one denominator, which is x times x minus 6. Almost done, children. So finally we get equals. I probably shouldn't write equals. There's no equal in this problem. I don't like equals. We'll just write it right underneath. 8x plus 30 all over x times x minus 6. Could you factor the numerator? Yes. Would it help you in this problem? No. But you probably should look into it. Oh, am I on? Ooh, I think I'm live. I'm sitting here just being very quiet. You're probably, what's going on? I wanted to blow that up, make it look better. All right. So this has an m squared, and this has a 2m. So my common denominator, if I look at just the m squared, you want to take the largest of those two. So in this case, it would just be m squared and m squared, right? I can do something to make m squared, make it m squared, right? Well, I really don't have to do anything, but I can do something to that m to make it m squared by multiplying by m. Now, we've taken care of the m squared. We know that we've got to have an m squared. But what about this 2? Oh yeah, we have to have a 2 down there. So every factor that's in the denominator needs to be represented once. So I need also a 2. So to change this one, I have to multiply numerator by 2 and denominator by 2. So that would be 14. This one I had to multiply denominator times m. So I got to multiply the numerator times m. And I get 5m. So my answer is, written in standard form, 5m plus 14 all over 2m squared. Keep these in parentheses so you don't do anything dumb like cancel those m's out, which clearly cannot be done. All right, let's take a look at this one. What was that first step I said? Factor the denominators. Now, we haven't had to do that yet, but this one we do. We have to factor the denominator. Actually, we can't factor the denominators. I apologize. I misread that one. I thought this said 2x minus 4. So I'm going to wrap these in parentheses. Neither one of these can be factored. Sorry. Neither one can be factored. But what I said in the directions is find the least common denominator, and you need each factor. You need every factor represented once in the denominator. So if I look at these and I say, okay, in my common denominator, I need x plus 4. It needs to be represented once in each denominator. Oh, I have a 2x minus 1. That needs to be represented once in each denominator. So there is my common denominator. So I say, oh, you multiplied this one to get to here. You multiply by 2x minus 1. So I got to multiply the numerator by 2x minus 1. I'm going to write that out. 2x minus 1 times x minus 2. And these probably should be in parentheses, so you think of them as being binomials. To go from here to here, I had to multiply by x plus 4. So I multiply the numerator by x plus 4. So this is x minus 3 times x plus 4. Now, the key is, and I'm just going to do this real quick, the key is if I got rid of this and this, isn't this that fraction. So they're equivalent. If I divided out the common factors, they would go back to the original fraction. Again, if I canceled this with this, I would have my original fraction here. So they're equivalent. All I've done is rewrite these as equivalent fractions with a common denominator, because that's important. It's absolutely mandatory when adding and subtracting fractions, especially rational fractions. So the denominator, now that I have a common denominator, I keep that denominator, and I got a whole lot of messing around to do with this numerator. So let's double distribute this thing. So we're going to get 2x squared minus 4x minus x plus 2. That's the first one. Second one plus x squared plus 4x minus 3x minus 12. All right. So now we just got to clean this baby up. Let's go. We got 3x squared minus 4x and plus 4x. They cancel. So minus x and minus 3x is minus 4x. And positive 2 and negative 12 make minus 10. All over x plus 4, 2x minus 1. Now, I really need to make sure that that numerator cannot be factored. I got to check, because if I can simplify this, I have to simplify this. So I need to check to see if this thing can be factored. I could go through and think about all the different ways to factor it and see if I'm right, and I might miss it. But the easiest way to tell if this is factorable is to take a look at the discriminant. So let's just take a look at the discriminant. The discriminant, if you'll recall, is b squared minus 4ac. b squared is 16 minus 4 times 3 times negative 10. So this is 16 plus 120, which is 136. Because that's not a perfect square, 136 is not a perfect square, this is not factorable. It is not factorable. That's it. Can't do anything else with it. Okay. Let's wrap parentheses around this married couple. We can see then we have an x minus 4 that belongs in my common denominator. Gosh, I should have been an opera singer. X minus 4 over here. Okay, so the x minus 4 goes into both, but we also have an x that belongs in both, x and x. That's our common denominator. This one we had to multiply both of these by x to get the equivalent fraction, so this is x squared. This one we had to multiply both by x minus 4. So I get 2x minus 4. Well, now that I have a common denominator of x minus 4, let me distribute here. I get x squared plus 2x minus 8. But, like I said before, you have to check to make sure things are still factorable. Or you have to make sure there's no more factors that can be divided out. So I have to factor that numerator if I can. And this one's a relatively easy one to look at and see, yeah, that's factorable. It's x and x, it's plus 4 and minus 2. So it is not factorable. It is not, you can't simplify it anymore. That's it, you're done. Even though that's x plus 4 and x minus 4, those don't cancel. Don't do it. Don't do it. All right, let's take a look at this one. So the first thing we're going to do with this one is put parentheses around this, obviously. But we're going to factor. So this is x plus 2, x minus 2, plus x plus 2, x plus 2. So now I factored it. All right, so now we got to make sure on what's going to be in our common denominator. Well, I need an x plus 2. I need an x minus 2. Oh, I have an x plus 2. Wait, I need another x plus 2. I do. I have to. So that's my common denominator. 2 x plus 2's and an x minus 2. Think about it like this. If this was an x and a y, because they're completely different terms, and this here would really be x plus 2 times x plus 2. Since x plus 2 is x, this is really x squared. So I really need an x squared in the denominator. I have an x. I need an x squared in the denominator. That's why I need 2 of these babies, okay? So my common denominator is x plus 2, x minus 2, x plus 2. So, what did I need to multiply this one by to get this? Well, what's the new thing? Oh, it's the extra x plus 2. So this one gives me 2x plus 2. This one was missing the, obviously, x minus 2. So I'm going to distribute that. I'm going to put that on the numerator, 3x minus 2. All right. I like to save a little bit of time here, so I'm going to clean up right here. This is 2x plus 4. This is 3x minus 6. So, keep the denominator, x plus 2, x minus 2, x plus 2. All over, let's see, 2x and 3x is 5x. Positive 4 minus 6 is negative 2. Yay! Oh man, I always love it when I get these rings. Subtraction. All right, I said it. I warned you about it a little bit earlier. Subtraction has its own issues. Hold on, I might need to pause for a second. So subtraction has its own issues. It's really just with that minus sign. So you're going to see change subtraction. This is, we're going to add a new step at the beginning. New rule. We hate fractions. Write it right here. We hate. Oh, not fractions. We don't hate fractions. Subtraction. Subtraction causes us all kinds of problems. So the first things we're going to do is say, I'm getting rid of the fact that we have a subtraction. And we're going to change it to a positive, and we're going to move that negative forward. And then you'll notice the rest of the steps are going to be the same. Ding, 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 ding. Simplify. So let's see how this is going to look. And I like to do this in a different color. So I'm going to do this in red. I hate subtractions. This is exactly what you need to do. You need to say, okay, I'm just going to distribute you up here. I'm going to move you. I'm going to move you up here. And I'm going to change this to a plus sign. Because really what this is now is 4 plus negative 3, which is really 4 minus 3, which is the same as 4 minus 3. I don't know why it's not going away. So we're going to change this to a plus and move the negative up here. Trust me, it's important. Oh, you don't trust me? Put parentheses around your binomials. Mean people. All right, let's do this. We have to factor both of these. So out of this first one, I can take out an x, and I'm left with x minus 3. Out of this second one, I can take a 2, and I'm left with x minus 3. Negative 3 and 4. So now I got to look at the denominators. I see an x. I see an x minus 3. And I see a 2. So each of those pieces needs to be represented in my common denominator. So I need to have a 2, I need to have an x, and I need to have an x minus 3. I need to have a 2, I need to have an x, and I have an x minus 3. So each piece needs to be represented in the denominator. And then you just go back and say, oh, okay, this one is just missing the 2. So 8. This one is just missing the x. Oh, minus 3x. All right. So we end up with is 8 minus 3x, put them in parentheses, all over that common denominator, which is 2x, x minus 3. Catching. You can leave it like that. That's fine. Wow. Wow. Does this one look really difficult? It's not. Not a fan of what that was in. Okay. So, you got random stuff in parentheses. So I got this minus sign. I'm getting rid of this minus sign. Don't like it. Don't want it around. Don't want anything to do with it. So what I'm going to do is I'm going to make this a plus by distributing that minus to both of these. So this becomes negative x plus 2. I distributed that negative to both of those. You got to remember to do that, kiddies. Don't forget. Now, if you don't like that, what you could do is just this. I could just do this and put the minus right there. So maybe that's easier for you to think about. So let's leave it like that, because I think it'll be easier when we do the next step anyway. So why don't we just leave it like that? That's okay. So we're going to go pling, pling, plus. All right, so we got to factor these denominators. Let's see. This is just x, and we're going to leave this as minus x minus 2. So let's factor these denominators. Let's see. I know that they both have to be the same because that's plus, and they both have to be negative. So negative 3 and negative 6. X and x. They got to both be the same, and they both got to be negative. Multiply to 24 and add up to 10 minus 4 and minus 6. All right, so let's see. I see a minus 3. Don't see another minus 3. I see a minus 6 and a minus 6 and a minus 4. So all of those pieces need to be in my common denominator. X minus 3, x minus 6, x minus 4, plus x minus 4, x minus 6. And this one is missing the x minus 3. So this one I have to multiply by. It's missing the x minus 4. And this one is missing, what was it? Missing x minus 3. That's right, x minus 3. All right, so then what we're going to do now is going to rewrite it. Plus, keeping the denominator, x minus 3, x minus 6. Is that behind my big head? Sorry, let me move that over a little bit, up a little bit. Maybe that's better. X minus 6, x minus 4. So that's the new addition there, the x minus 4. And then we got x minus 4, x minus 6, x minus 3. Whew, hands tired. Let's distribute. Let's multiply this out right here. Actually, let's just write it. X times x minus 4. Let's just write it like that. And over here we have minus x minus 2 times x minus 3. All right. Now, I'm going to do the work a little bit right above here. So if I distribute this, I get x squared minus 4. So what we're going to do is going to keep the denominator, x minus 3, x minus 6, x minus 4. And this piece over here becomes x squared minus, it's x squared minus 4x. Got to remember to distribute that thing. So x squared minus 4x. Well, that would have been a bad mistake. Would have had the wrong answer. Over here, I'm going to double distribute over here. So I get x squared minus 3x minus 2x plus 6. So this is really a minus 5x here, right? These two. So what I get now is minus, because we really got a minus here, minus x squared minus 5x plus 6. That minus is always problematic. Just be careful of it. What's this doing on here? So let's distribute that negative. So we get x minus 3, x minus 6 and x minus 4. Let's save ourselves a little bit of time here. I don't want to have to rewrite this 2 more times. So we're going to distribute this negative. That makes this negative. We're going to distribute it here. That makes this positive. We're going to distribute it here. That makes it negative 6. So we have x squared and minus x squared. Well, those just cancel. We have minus 4x and positive x, or 5x. So that's just x. If I put this minus 4x together with this positive 5x, that just gives me x. And then minus 6. Well, wait a second now. I'm not done yet then. Wait a second. Then doesn't this x minus 6 cancel with this x minus 6? Now just be careful. Remember, x minus 6 goes into itself once. X minus 6 goes into itself once. So I end up with 1 over x minus 3 times x minus 4. Be careful. And again, I would check it. I would check a value for x there. I would check a value for x up here and verify that they work, because this was a nasty one. I think we got one more. Oh, this one looks like so much fun. What is that? What is that? Woo, baby. I'm going to have to take a break and come back to that one. This, my friends, is another one of those problems. If your parents ever ask you, what are you doing in math class? Mom, can you help me with this problem? Dad, can you help me with this problem? I'm a little bit stuck on it. They'd be like, no, not at all. I don't even know what that is. You got A's and B's. It's fractions. I don't even know. Can't do it. All right, kids, first things first. Let's get rid of those minuses. They're problematic. First of all, we're going to put parentheses around everything that's being added and subtracted. Married couples, put them in their wedding rings. Now let's get rid of the minus. Plus, negative. Plus, negative. So this is the, I forgot the minus. This is the really one that's the only one that's going to be really problematic is that one. That's going to give us the most grief. So we just got to be careful with it. All right, so now let's factor everything. So this is going to be 2 over a minus 2b. Or not to be? That is the question. Oh, gosh. Little Shakespeare for you in the morning. Or in the evening, or whenever you're watching this video. For me, it's in the morning, of course. This is dots, difference of 2 squares. So this is just a minus b, a plus b, plus negative 6b. Now, this one's a little funky cold Medina here. A and A, that's a reference from like the 80s. Really bad song, by the way. Let's see. They got to multiply to negative 2 and add up to negative 1. So let's see. That would be minus 2 and positive 1. But minus 1b and minus 2b, or plus 2b. Or not to be. All right. So let's look at the 3 denominators now. What do we see that's in the 3 denominators? I see this. A minus 2b. So that has to be a part of my common denominator. A minus 2b. I see an a minus b. A minus b. I see an a plus b. A plus b. I see an, I already got an a minus 2b in there, and there's not one of them has 2. So we only need one of them. And I already see an a plus b, so, okay, that's already down there as well. So there's my common denominator. A minus 2b, a minus b, and a plus b. So I'm going to write this under each fraction. I should have picked a smaller pen. A minus 2b, a minus b, and a plus b. Plus, uh-oh, big head's in the way. You're going to have to just verify that a minus 2b, I'll pick it up in a second, a minus b, and a plus b. Got to get a smaller pen. Oh, not that one. So, this one was missing 2 things. It's missing the a minus b and the a plus b. Because it only had 1, and there's 3 down there now. This middle one is only missing, what is it missing? A minus 2b, right? So a minus 2b. Don't forget that nasty minus. a minus b, a minus 2b. And this one is missing just the a minus b. So negative 6b, a minus b. There's like zero chance of me finishing this before I have to take a quick break. Let's see what I got. All right. I'll clean it up a little bit. So, a minus 2b, a minus b, a plus b. This one's new numerator is going to be, whoa, let's back up the crazy train here. So let me double distribute this. I get a squared minus b squared. Isn't that just dots? But I got to multiply by 2. So I get 2a squared minus b squared. Minus 2b squared. Got to distribute that 2. So 2a squared minus 2b squared. I just distributed the 2. All right. This one I got to double distribute. And I get a squared minus 2ab minus ab plus 2b squared. Now we might as well distribute that negative while we got it. So we just might as well do it right now. We're going to distribute that negative because we got that nasty negative out front. So first and foremost, this is minus 3ab right here in the middle here. So we're going to distribute this negative. Minus a squared plus 3ab minus 2b squared all over a minus 2b. You should have asked for help on this one. A minus b. Dad, Mom, do you see why I hate math? Plus a minus 2b or not to be. Oh, I just want to say it every single time. I don't even know why. It's just like a habit. It's like bad habit. Shut up. All right, distribute. Negative 6. Now, I always put the letters in order. B-A I could write, but I'm going to write it as A-B because I just put them in alphabetical order. It makes no difference. Minus, plus 6b squared. Well, now that I've gotten the common denominator, and I'm just about done then. Let's see. The common denominator is a minus 2b, or not to be. You know it's coming. You know it's coming. A minus b, a plus b. All right, so now we got a whole bunch of cleanup work to do. So I've got, let's see what we got here. We got 2a squared minus a squared. So that gives me just a squared. Now let's do the ABs. I got 3ab and minus 6ab. So that's minus 3ab. And I've got negative 2b squared, negative 2b squared. That's negative 4b squared. And 6b squared, so that's positive 4b squared. Sorry, I was just looking down at my answers because I didn't want to make a mistake, and I think I realized I made a mistake. Did you see my mistake? Math is... Problems like this, you know, you're like, oh, I'm done. And they're like, oh, I made a dumb mistake. Hey, come on. I'm doing all the hard stuff right and screwed up this number. Negative 2 and negative 2 is negative 4. Plus 6 is just positive 2b squared. Now you think, oh, my God, finally I'm done. Oh, no, you're not done. That has to be factored to check. Because remember, the last rule here is rewrite as one fraction. And then... simplify. Last step is to simplify. So we got to see if we can simplify this thing. So let's see. How can I rewrite this? The denominator we're not going to mess with. It's just a minus 2b. Or not to be. Oh, that's so old. All right, let's check this numerator out. What multiplies to a squared? Oh, that would just be a and a. What multiplies to 2b squared? Wait, it's positive, so that means the signs have to be the same, and they both have to be negative, 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 and b and 2b, right? Because that would multiply to positive 2b squared. All right, so this is the factored form. Can anything be canceled? Oh, yeah. A minus b and a minus b. Anything else? Oh, my goodness. A minus 2b and a minus 2b. Now, don't be silly. Remember, a minus b made 1 over 1. A minus 2b and a minus 1 over 1. So my numerator still has a 1 in it. Then this is in the denominator. A minus b. Excuse me, a plus b. All of that up there turned out to be a plus b. Now, again, you can check your answer. Store a number in for x. Let's see how long this takes. Okay, I'm going to keep this timer up there. It's my recording software, but we're going to keep this timer up there to see how long of our life we're going to waste to check this answer to see if they verify that we're correct. So, first thing we got to do is store a number in for a and b. 2.14 store var a. All right, that doesn't count. 2.14 control var a. Enter. 3.25 control var b. B. Enter. Now, it'll probably be in my best interest to move this over here. So, let's see. It's taking more time just to move stuff. All right, so control division. 2 over a minus 2b. A minus 2b. Out of that, minus control division. A minus b over a squared minus b squared. Minus control division 6b over a squared minus a, you have to write a times b, minus 2b squared. Verify that that is in fact the fraction that you have there. It is. Our answer was control division 1 over a plus b. Enter. Oh my gosh, it took less than 2 minutes. It actually probably took about 1 minute and 10 seconds if you've taken all my mistakes. But there you go. You verified that you got the right answer in less than 2 minutes. Probably you could, because you're a lot faster than I am, probably could have done this in about 45 seconds. Store a number, check the original, check your answer, verify that they work. If they don't get rid of your work. Just go back and see if you can find maybe a place you made a simple mistake. All right, kids, I'm out. That is 5.5. Yay! It's so exciting. Bye.